to the first presentation of the day. I'm very excited here to have Scale Computing joining us, and we have now got Craig Theriak. I hope I said that right. Craig, I didn't actually ask you before this how to pronounce your last name. Vice President of Product Management is now in the house and going to be joining us live. Craig, it is great to have you here today. The floor is yours, sir. Take it away.
Cool. Thank you, Keith. And you had it close. It's Craig Theriak, but to be honest, I've had several names in my life, and I'll respond to just about any of them. So thanks for having me on today. I've got a lot of slides to get through, but I'm going to try to actually spend the majority of the time on a demonstration of the products. I think you can really get into the meat of what it is that we do at Scale Computing, how we can provide the reliability and resiliency you need in your infrastructure if you're deploying at the edge. Before I actually get into that, though, it's real quick. Let me tell you who Scale Computing is. We were first founded in about 2007, 2008 timeframe. I've actually been with the company for a little over 13 years now, and we, in the 13 years I've been here, have reinvented ourselves a few different times. Sometimes it was very intentional. Other times, like in the case of creating a product that works really well for the edge computing space, it was a little serendipitous. If you've heard of Scale Computing before, you likely have heard of us in small and mid-sized organizations. We created a product that we call HyperCore that runs on premises, that allows a user to set up infrastructure, run legacy and even containerized and kind of cloud-based or cloud-native workloads on top of us, and provide infrastructure availability. It's a really easy to set up product, and we've amassed thousands of customers in that space, of really happy customers using the product. What we didn't realize was until around 5 years ago that the product we created that worked really, really well for small businesses where they need availability, scalability, and simplicity was that the core tenets of the design of what we created in that product worked really well in distributed enterprises. And so what's happened is over the last 5 years, we've had this pull into these types of environments, which we often now call edge. Edge, though, as a term is it's pretty loaded. It really is one of those terms that can mean just about anything. When we talk about edge computing at Scale Computing, we typically will refer to it as anything outside of the core data center or cloud. And there really is a spectrum. Everything from regional data centers where you might be running us in an infrastructure as a service type of offering. Local data centers, very common for small and mid-sized organizations to have that. And then the further out that you get into the far edge, that's more aligning with what most of you probably think of as edge computing now, which started its roots in more robo style of deployments, but it's distributed enterprise. It's distributed environments where you may have hundreds or thousands of sites with minimal compute needs, but still the same level of resiliency requirements and reliability requirements that you might have in your regional data center or local data center, or even your core data center. So with that as a backdrop, some of the challenges that we typically will see in these environments go beyond just the requirements around reliability and resiliency. And you'll kind of see some of these bleed together as we talk through them. But in these environments, you almost never have anyone that has IT staff, kind of the qualifications to either set up or manage the infrastructure that has to go on premises. Again, going back to our roots in small and mid-sized organizations, that was exactly who we designed the product for. And around 5 years ago, when we started to be brought into these distributed enterprise environments, it basically went from 1 to 5 IT administrators now to 0 IT administrators on premises that have the technical expertise to manage the infrastructure. Oftentimes in these environments, there are physical constraints, and that goes beyond just the needs to be a small form factor type of environment where it's sitting under a desk somewhere, or sitting in a telco rack in the back of the room. The physical constraints also extend to what you would expect from power, what you expect from cooling, even physical security in these types of environments. It's very different than what you might have in a tier 1 data center or even kind of a cloud environment. Connectivity and outages is another one that comes up really often in edge environments where you may not always have a connection you can rely on to the internet, and as a result, you need to operate in an autonomous fashion, and so you have to expect that there might be outages in that connectivity, and so you need to be able to run kind of offline from a connection into the internet. And then finally, unpredictable demands. Almost every customer that I talk to these days has some application that is either being driven by an internal line of business team, an application team, or sometimes even a third-party application team, where they're being asked for machine learning, AI types of workloads that are being brought into the environment to either increase top-line revenue or decrease costs, or sometimes having to deal with even local security, that type of workload. They don't exactly know when it's going to come, what the requirement's going to be, but these unpredictable demands of I need to make an infrastructure decision of what I'm going to purchase in the next, say 6 months, 12 months, and that's supposed to last me for the next 3, 5+ years. If not exactly what I'm purchasing, something that can grow into what exactly I need, which falls in this unpredictable demands timeline. The infrastructure itself, like what we do at Scale Computing, is try to provide an answer to those issues. We provide a product that has high availability baked in. It's really easy to set up, really easy to manage. You don't have to have IT resources on-prem to deal with it. I won't spend a lot of time on the efficiency of the product today, given that the topic is more around reliability and resiliency, but we have a really interesting efficiency story that allows us to run on smaller form factors, both for the size of being able to, in these physical constrained environments, be able to put these hardware platforms in place, but also just the efficiency of the software stack to maximize the amount of I/O and other attributes of the workloads that are running there on premises. And then finally, the flexibility to be able to scale out the infrastructure to meet whatever the growing demands are on that infrastructure in the future. So with that, I'm going to transition into more of a demonstration of the product. And please do keep questions coming as they're coming in. I think the Action Tech Media team is really good at sorting those and handing them over here so I can try to answer them in real time. And then Keith, I'll just ask you if there's something I don't see, definitely call it out verbally and feel free to interrupt to make sure that I'm answering all the questions that do come in. What you see on screen here is what we call SC Platform, Scale Computing Platform. The SC Platform is broken down into really two main components that you'll see me go into. One is HyperCore, which you see along the bottom there. That is the software that runs on premises on physical hardware that provides the high availability. It's basically pulling together storage, servers, hypervisor, a whole lot of advanced disaster recovery functionality that we'll try to cover here today into an appliance-like solution for running your legacy workloads as well as more modern applications like containers. We then have, see on the left-hand side, Fleet Manager. Fleet Manager you can think of as a management and orchestration tool that is cloud-based, that it allows you to provide visibility and orchestration across your fleet of HyperCore clusters. So I'm going to share my screen here, and you should see Fleet Manager. So here I'm pointing to fleet.scalecomputing.com. Again, this is the cloud-based tool that's going to allow me to manage my fleet of HyperCore clusters. I'm going to log in with Google, and you'll see in my fleet I have 40 some, maybe 50, 41 clusters in this fleet. And we've got customers that have thousands of clusters. But the idea is you've got a dashboard that just tells you at a glance, what is the health of my entire my entire fleet of HyperCore clusters. For today's demo, though, I'm going to actually focus on just a single site here, what I call Store 301. So this is a 3-node system, as you see here. Each of these nodes has a single drive, single CPU, a handful of cores. Here's the utilization of that, a handful of running workloads on here. I'm going to use a feature that we call Secure Link to actually go into this cluster. So you'll notice what's happening here is there's an outbound connection made from the cluster to Fleet Manager to this proxy service that allows me to reach the user interface of HyperCore without actually having to have a VPN or having to have an SD-WAN into that site. So here there we go. Here's the HyperCore user interface. You can kind of see the difference here between HyperCore and Fleet Manager. Here I'm in HyperCore. So again, just to kind of throw back to that last slide where we talked about the overview, this is the section now where I'm on a 3-node cluster. You can see that represented by these nodes here at the top that is running on premises. This happens to be in my lab sitting right next to me, which is nice because I can do things like pull a node out, which I'll try to walk through as part of this. Usually when I'm demonstrating the product in a lot of detail, I'll go through the simplicity of being able to create the workloads. I'll talk through the scalability of being able to add additional nodes, as those change, those unpredictable demands hit, and you say, "Oh, I need to add another node that requires X resources." You just add that in, and it quickly aggregates everything. What I really want to focus on here today, excuse me, is more the what I would call day two operations here. So you think through the life cycle of having infrastructure out at the edge of your environment. When you're really talking about maximizing reliability and resiliency, a lot of that focus comes down to day two. Yes, the product has to be easy to set up. We have zero touch provisioning that allows you to set these things up without having any IT resources on premises. Then you have to get your applications onto this. And usually in a longer demo, I'll walk through even using we've got a Red Hat Ansible certified collection that allows you to basically create workloads on the fly and interact with the infrastructure as code and define, this is what I want this site to look like, and pull in all the applications. The focus today, though, is going to be on day two and somewhat on day in with adding additional applications and new resources to expand the environment. So on day two, here I've got a day two system. This is stood up out at my site. Here on the top here, you'll see that I've got a handful of workloads that are running on the system. I could actually even still through secure link get to the user interface of the guest itself and log into Windows, do whatever administration I need to do from that. But I thought what might be interesting is actually to walk through a failure scenario. So we're talking about resiliency of the infrastructure. It's how do you tolerate things like node failures? And one of the things that I think sets scale computing apart from a lot of other products out there in the market is that we have built-in AI ops in a layer that we call AIM. So it's Autonomous Infrastructure Management Engine. And that infrastructure or that orchestration engine really is designed to monitor what's going on in the cluster and then make real-time decisions based on what needs to happen to get to a better desired state. So the way this works is at the lowest level, we have what we call collectors. And you think of these as really small collections of data, thousands of these across every node in the system. It's everything from temperature to just environmental things that are happening. The layer above that is kind of what we call checked values. So we're collecting data at the lowest level. The next layer up, we're deciding, does that value that I'm receiving fall within a range that I can rely on it? In the event of, I mentioned temperature, right? So if the temperature falls in a range that is beyond obviously what is realistic, we're not going to rely on that data to make decisions based on the data. The next layer up then is actually where we start to set conditions, which is what you actually see in the user interface here. These are set in the UI here. They are sent out through syslog. They're sent out through email. They also will populate up through Fleet Manager for that kind of single pane across all of your hypercore clusters out there in the field. But what's actually happening under the hood here is that we're recognizing undesirable states. And so we're looking at, again, all these conditions in the cluster. And then based on that condition, we know what the desired state is of things going on in the cluster, such as, I've got a handful of workloads that are running on here. I want to keep those workloads up and running. The desired state is on, which means if this node fails, which it looks like it's recognized that there's data redundancy or degraded, there's a reason that, this node is unavailable. Any workloads that were running on this, in fact, if you were looking closely, you may have seen that pharmacy application that went offline. We know the desired state of that application is online, and we'll automatically restart it for you. And this is just an example of some of the power that's built into that orchestration layer. It's working in tandem with a storage layer underneath that we call Scribe that is actually placing blocks kind of across every node, every drive in the system in a way that we call wide striping. So we can make sure that, essentially any data that exists on this node 2 that's failed exists somewhere else in the cluster. That's what allows us to tolerate drive failures. That's what allows us to tolerate node failures like you see here. That's also actually what allows us to do things like live migration of workloads. So I'm going to plug that node back in. The AIM orchestration layer is pretty powerful. In addition to detecting things going down, it's also able to heal itself, right? So if this node gets plugged back in, which I've just plugged back in, you'll start to see it go through this exact opposite process of saying, okay, this node is online. I can communicate with it. The data is no longer degraded, and you'll start to see these conditions clear itself. And the system will even, if you have that workload that restarted another node in the system, if you've got affinity to a certain node, it will migrate automatically back to whichever node you have it placed on. Looks like I've got a question in here. Yeah, so one of the questions that I have in here, I'll try to answer these as we go. So no on-site IT resources required to maintain the system. What types of reporting and feedback can Scale provide for the customer? If customer identifies need to change that covered under regular maintenance. Yeah, so requirement of needing no on-site IT personnel. So let's just walk through a handful of situations. One is this exact one, right? So node failure. So we're in day 2, something's failed. What do we do? So in this particular case, the workload has automatically restarted, which means the applications running within that particular VM are back up and operational. Then kind of out of the heat of this node being down, we can do a node replacement. And that node replacement simply is you add another node into the system and remove this node, which can all be done remotely. The physical seating of the node has to be done on premises, but that can often, in the case of my store 301, can be done by the store manager. It doesn't have to be a technical resource. It could be the most technical resource you have on premises, but maybe not necessarily rolling a truck with an expensive IT resource to deal with that failure. But you can really think through the need for IT resources through the entire life cycle. On day 0, things like zero-touch provisioning. So we have within Fleet Manager the ability to go in and create a new cluster and define, which nodes are going to be part of this cluster. And based on those nodes, when they come online, I can assign it a profile and say, here are the configuration that you should have by the time you set yourself up. When somebody plugs in power and plugs in networking, there's a secure mechanism that reaches out to Fleet Manager, receives this configuration file, and then usually 10 to 15 minutes later, the cluster's up and operational, and you can start adding workloads on that remotely. So there's a lot of tooling around this. The assumption that we have is that most customers do not have ready IT resources on premises, and so any decision we can make to alleviate that need is what we're going to do within the product. Great question. Okay. So let's go back here. It looks like the cluster is healing itself. The next thing I really wanted to touch on was, I talked about the unpredictable nature of a node failing and dealing with application or high availability within the infrastructure. Obviously, there's a lot of customers that we have out there that are starting to bring in Kubernetes and just containerization in general, and actually building application level availability as well, which is great. I think it's a great solution to making sure that you're minimizing the downtime for the running workloads. And just want to make sure that I call out that while I'm demonstrating a lot of VMs in this case, application level availability works right alongside this, and you can run those workloads exactly as this would be run right next to those legacy VMs. The next thing I want to cover is more of the planned downtime. So part of day 2 is maintaining that you have the right level of BIOS and firmware and the latest update applied across your fleet. And within Fleet Manager, I don't know if you saw on that initial dashboard, you kind of had a visual of here are all the versions that are out there in my fleet. To update a version is actually pretty simple. So what we do at Scale Computing is we maintain the entire update for the entire system for our customers through a single click. So when an update's available, it's actually going to show up here in the user interface and basically provide a release notes and all the information you would need to be able to apply that. You'd click a single button, and we make use of live migration and just migrate the VMs around as we need to, updating everything in the stack. So we'll start on node 1, we'll migrate all the workloads off of node 1, then we'll update any critical BIOS firmware updates. We update the storage stack, the operating system in which we're running. We update the hypervisor that we include as part of this. That orchestration layer that I talked about, and all that, of course, is tested together in kind of an atomic unit, so we can assure that this update's going to work. And then once that node is up and nominal, and sometimes we'll have to do restarts to apply some of these things. Once that node's up and back and rejoin the cluster, AIM kind of handles that process of rejoining. Then we migrate workloads back to that node, and then we go to node 2 and we do the same thing, migrate all the VMs off, update everything we need to, and rinse and repeat all the way through the entire cluster. So in that mechanism for providing updates can also be done directly from Fleet Manager as well. So you can read the release notes, whatever you need to do, hit start update, and it will kick off that process so that you don't necessarily have to worry about downtime related to keeping things up and making sure that you're protected against the latest patches that are out there. The last thing that I wanted to talk about here as part of this is just the data protection suite. So some of the more advanced functionality that we have built into HyperCore are things around our snapshots and replication. this is I would say this is one of the unsung heroes of the Scale product line is the fact that all of this is just built into the product. So you can go through and very quickly take a manual snapshot as often as you want. Of course, you can schedule these snapshots and create whatever schedule you want that to be on and apply a policy to whichever workloads you want that to be driven on. We often will see people, if they're testing an update of an operating system, we'll take a snapshot before, test that. If it works, great. They'll actually promote that to be the primary. If not, they will revert back to whichever one they started with. And those snapshots are, I don't know if you saw how fast that was, but they're really easy to take. They're also really easy to clone from. And you also have the ability to do even drive level cloning. So you can take a specific drive from a snapshot and mount it to another running VM within the cluster. And when I say mount it, it's actually not taking the snapshot and mounting it, it's cloning the snapshot and presenting that clone as a mount point on whichever VM that you have that on. So it's really handy for file level restore and those types of things. So in addition to protecting against infrastructure issues, you're also protecting against things like ransomware or other issues that might exist in the environment where you actually have to go back and recover from using snapshots. Let's see. Looks like there's a few other questions here. So how do you ensure interoperability and compatibility between edge computing devices and platforms from different vendors? It's a good question. So, the platform itself, again, this happens to be running on a NUC-based cluster. So really small form factor, 4x4. We have 1U, 2U rack mount options as well. A whole lot of just a giant breadth of certified hardware out there that you can choose from. That infrastructure, this user interface that I'm presenting here is going to be ubiquitous, though. It's the exact same no matter which hardware platform you're running on. The way we interoperate with the other devices that are out there, right? So if you've got IoT device that's sitting out there somewhere on the network and connecting into an application that's running on here, all that's usually done on a local WAN, and that's typically how that communication happens. For communication from Fleet Manager, from Hypercore back to Fleet Manager, that's all on MQTTS and a couple other protocols that we have built in there as well for communication outbound. And then privacy and confidentiality. This comes up this is a great question. I appreciate it, Johnny. I appreciate you asking this. So there's a question around privacy and confidentiality. So one of the things that I think is really interesting about the way we've architected this product is, first of all, everything we do is, let's talk about it in two different ways. Number one is Fleet Manager is a cloud-based service, and a lot of people are saying, well, if it's cloud-based, what information lives in here versus what information lives in Hypercore? All of the information that you see here in the user interface within Fleet Manager is kind of high-level usability information, like how much usage for CPU, memory, disk. You can kind of see information about the individual VM names and descriptions, but there's no actual VM data or workload data that lives within Fleet Manager outside of the metadata about those workloads. Of course, we've taken drastic measures to make sure that everything within Fleet Manager itself is secure, and using the latest protocols to make sure that is. And we of course do continual pen testing to make sure that all of that is working as expected. On the Hypercore side, though, this Fleet Manager, while we present Fleet Manager alongside Hypercore, it's not required. Hypercore, prior to the launch of Fleet Manager 3 years ago, Hypercore was just deployed by itself, and so you could take a cluster, run it, even in a dark site, and never have any connection externally. And so all of this would be living on premises under your kind of behind your firewall in your environment to make sure that is as secure as you possibly would want that to be. We'll commonly be run in PCI compliant environments, HIPAA compliant environments, and while the infrastructure itself, there's no such thing as a PCI compliant HCI cluster, it can be operated in an environment that has those regulations and requirements. That's really common. So another great question. A few other slides that I could kind of talk through here. As I mentioned, what I'm demonstrating on here today is the HE100. Actually, let me go back to our actual slide deck here. 1 second. Stop sharing my screen. Okay, so yeah, as I mentioned, I just did the entire presentation based on the equivalent of HE100 series, but all of the hardware that we provide, all the options that we provide has a very similar experience. I'll jump ahead to kind of the end result of all of this is that we have a lot of very happy customers out there that are running this on premises with a connection that it just basically is, you set it up, you just don't have to worry about it anymore. And whether that's in a small business or whether that's in an MSP that's serving hundreds of clients or whether that's in a distributed enterprise out at the far edge, that resiliency and reliability that we built into the product is it's spoken about in just about every review that you can find out there. We also have a really strong partnership with our resellers and MSPs out there in the market and continue to win awards around that. And I know I'm coming up on time here. So Keith, let me just jump to my thank you slide. And I want to say thank you for having me on today. I've enjoyed the conversation and I appreciate all of the great questions out there. Keith, are there any other questions that have come in that I can answer that make sure we're covering everything?
Well, there are more questions, Craig, but we are out of time, unfortunately. Okay. You had so much great information, but I will add that that Scale Computing and you likely will follow up with any questions that were not answered during the event today. So have no fear. For those of you who asked questions that did not get answered, Craig, I want to thank you so much for being on. Scale Computing is always doing such innovative things, and thanks for educating us on what's happening with Scale and edge computing. It was a pleasure to have you today.
Pleasure's mine. Thank you.